All right, let's get right into it. Today, we are tackling one of the most powerful and honestly, one of the most feared processes in all of project management: perform quantitative risk analysis. We're going to break down the ITTOs piece by piece so you know exactly how this thing works. This is about mastering it, not just for your projects, but for your exam too. Let's go. So let's start with a big one. What is the true cost of a guess you're absolutely 100% sure was right? Think about that for a second. This question, well, it gets right to the core of project confidence, and believe me, it is a classic exam trap. We're going to come back to this, so keep it in mind. And here's another one, a real head-scratcher that tests your strategic brain. Is a high-probability risk sitting right there on your critical path more dangerous than a medium probability risk, but this one is lurking at a point where multiple paths converge? How you answer this? Well, that's what separates a project manager from a true project integrator. And yes, we'll reveal the answer at the end. You know, so many projects fail, and it's not because of bad planning. It's because they're missing a calculator. Seriously, they're relying on these fuzzy, subjective feelings: high, medium, low. It creates this mirage of safety that just completely shatters the moment it hits statistical reality. Perform quantitative risk analysis. That is your project's calculator. It's the process that pulls us out of the guessing game and into the world of data-driven decisions. So let's talk about the first big piece here, the high cost of guessing. I mean, this is really the whole problem we're trying to solve, right? It's about getting past those gut feelings and into a world where we can actually calculate and manage the real cost of being wrong. Okay, next up, laying the analytic foundation. Before we even touch a single calculation, we have to burn one rule into our brains: garbage in, garbage out. It's that simple. The quality of our analysis, of our results, is 100% dependent on the quality of the stuff we feed into it. So, what do we actually need to get started? Well, first, you got to have your risk management plan. That's your rule book. It tells you if you're even doing this, and if so, when and how. Next, you need your baselines: scope, schedule, and cost. I mean, you can't measure the impact of a risk if you don't know what you're measuring against, right? That's your stable foundation. And of course, you need the risk register itself. That's your list of suspects, the specific risks we're actually going to put under the microscope. All right, with our foundation laid, it's time to open up the analyst's powerful toolkit. Think of these as the precision instruments we're going to use to take that vague feeling of doubt and forge it into cold, hard, actionable data. You know, the first two tools in the box are all about people. It starts with expert judgment. We need someone who knows what they're talking about to help us translate those qualitative insights, the what-ifs, into actual numbers that our models can understand. Then we move to data gathering. This is where we do things like interviews to actually pin a number on the probability and the impact of each one of those risks. And this brings us to an absolutely critical concept: representations of uncertainty. Look, a single point estimate, saying a task will take exactly 5 days, is a fantasy. It's almost always wrong. The real world doesn't work that way. We have to think in ranges. And that, right there, is why probability distributions are so important. Okay, so we generally use two main types here. First, you've got the triangular distribution. This one's pretty straightforward. It just uses your 3-point estimates: optimistic, most likely, and pessimistic, and kind of averages them out. But then you have the beta distribution. This one's a little smarter. It gives more weight to that most likely number, which makes it way more accurate, especially when you have good historical data. The whole point is to reflect how things actually work, with all their variability, instead of just clinging to a single hopeful guess. All right, now we're heading into the real engine room of this whole process: modeling the project's future. This is where the magic happens. We're going to use some seriously powerful techniques to simulate our project's future, not just once, but thousands upon thousands of times. And the undisputed king of this engine room is Monte Carlo analysis. So what is it? Well, imagine a piece of software that literally runs your project, say 10,000 times. And each time it picks a random value for each task from those probability distributions we just talked about. What this does is let us see the combined effect of all the risks hitting at once. This is huge, especially at those points where different paths merge, because that's a massive blind spot for most project managers. Now, Monte Carlo isn't the only tool in the box. We've got two other heavy hitters, and they do very different jobs. You've got sensitivity analysis on one hand. Its job is simple: find the individual risks that have the biggest, most powerful impact on your project.
Then you've got decision tree analysis. This one isn't about finding the biggest risk. It's about helping you choose the best strategic path forward when you're facing a fork in the road.
Let's dig into sensitivity analysis for a sec. The entire reason we do this is to know where to focus our limited time and money. It spits out this awesome visual called a tornado diagram, and what it does is rank all your risks by how much they can mess up your project. This is a game changer because it lets you laser focus on the real big hitters instead of wasting energy on a bunch of small fry risks that don't really matter. And for that decision tree analysis, our weapon of choice is called expected monetary value, or EMV. The calculation itself is dead simple. You just take the probability of something happening and multiply it by the financial impact if it does. So a 50% chance of a $200,000 hit gives you an EMV of $100,000. Why is this so cool? Because it rips all the emotion and gut feeling out of the decision. It lets you prove, with numbers, which path is most likely to deliver the best financial outcome. Okay, we've run the numbers, we've modeled the future. So what? Where does this all lead? This is section 5, from data to decisions. And let me be clear, the outputs here aren't just dusty old reports. This is pure, actionable intelligence that is going to directly drive how we plan our risk responses. And here it is, the single biggest payoff of this entire process. We can finally calculate the exact contingency reserve we need, both in time and in money. We are officially done with guessing. We now have a statistically justified buffer that we can present to our stakeholders and say, this buffer gives us an 85% level of confidence, or whatever the number is. It's a total game changer. So the main document that comes out of all this is our updated risk report. But it's not the same report that went in. Now it's packed with a full assessment of the project's overall risk exposure. It's got detailed probabilistic analysis, complete with those cool S-curves from Monte Carlo, and the tornado diagrams. And most importantly, it's got a crystal clear, prioritized list of the risks that truly matter. Which brings us to our final section, becoming the master integrator. It's time to circle all the way back and finally answer those questions I threw at you at the beginning. Because mastering this process, this is what elevates you from just a manager to a true integrator, someone who navigates the fog of uncertainty by design, not by blind chance. So let's revisit that first question. After everything we've just gone through, what is the true cost of a guess you were absolutely sure was right? The answer? It's what I call the integrator's gap. The real cost is being completely blind to the thousands of possible futures that a simulation would have shown you. It's the cost of running a watermelon project. You know, green on the outside for all the stakeholders, but a complete chaotic red on the inside. It fails because you never saw that invisible, numeric thread of risk that was weaving its way through your entire plan. And now for that second exam trap. So which one is it? The big, scary, high-probability risk staring you in the face on the critical path, or that sneaky, medium-probability risk hiding out where paths converge? And the answer is, the risk at path convergence is very often the more dangerous one. Why? Because simple qualitative analysis, just looking at high, medium, low, will miss it every single time. It's only through a Monte Carlo simulation that you can see how several, smaller, seemingly unrelated risks can all pile up at that single merge point and create one gigantic project-killing threat that you never saw coming. So here's the bottom line. A master project manager uses quantitative risk analysis for one simple reason, to turn their blind spots into a detailed map. It's how you make sure your project succeeds by design, not by dumb luck. Thanks for tuning in, and never stop analyzing.